Imagine slowly filling a glass of water. As time passes, the height of the water rises. Notice how these two quantities, time and height, change together, always in step with each other. This relationship between two variables is called change in tandem, the central idea of Unit 1.1. Welcome to AP Precalculus Topic 1.1, Change in Tandem. By the end of this lesson, you will be able to describe how input and output values vary together, analyze increasing, decreasing, and concave behavior on a graph, and identify zeros and positive or negative intervals of a function. Where we're starting from. You already know algebra, functions, and graphs from earlier courses. Topic 1.1 places you at change in tandem. You are here. After that, rates of change comes next. A function is a rule. You give it an input, any value from its domain, and it produces exactly one output. No input ever gets two different outputs. That is the defining rule. We call the set of all allowed inputs the domain, also known as the independent variable. The set of all outputs is called the range, or the dependent variable, because its value depends entirely on the input. Here is the graph of a function f of x. A function is increasing on an interval when, as the input increases, the output also increases. Think of going uphill. Both x and f of x rise together. A function is decreasing when the output falls as the input rises. The curve slopes downward. We always describe these intervals using x values. Formally, if a is less than b and f of a is less than f of b, the function is increasing on the open interval from a to b. Now let's talk about concavity, a deeper look at how a function changes. Concavity describes whether the rate of change is itself getting bigger or smaller. On the left, the slopes of the tangent lines grow steeper as x increases. The rate of change is increasing. We call this concave up, like a bowl. On the right, the slopes flatten. The rate of change is decreasing. We call this concave down, like a hill. The point where a graph switches from concave up to concave down, or vice versa, is called a point of inflection. Let's look at another function. The zeros of a function are the x values where the output equals 0. In other words, where the graph crosses the x-axis. This function has three zeros, at x equals 1, x equals 3.5, and x equals 6. Between the zeros, the function is either entirely positive, above the x-axis, or entirely negative, below it. The sign only changes at a zero. In AP Precalculus, every function concept is expressed four ways. Graphically, as a curve on axis. Numerically, as a table of input-output pairs. Analytically, as an equation or formula. And verbally, a written description of how the quantities change. Let's wrap up. Remember these four ideas from topic 1.1. First, a function maps each input to exactly one output. Second, analyze behavior. Is the function increasing or decreasing? Concave up or concave down? Third, zeros are where the output equals 0, and the sign only changes there. Fourth, every concept can be expressed graphically, numerically, analytically, or verbally. That's topic 1.1, change in tandem. Up next, topic 1.2, rates of change. See you there.